Hello everybody, this video is going to be for our single replacement lab. We're going to talk about the reactivity series and also about how to predict the products of a single replacement reaction. So the first thing I'm going to do is highlight the elements that we're going to be using in the lab. So we're using both elements and compounds in the lab today. It's going to be, actually let's start over here, magnesium, aluminum. I'm going to use a different color to highlight iron, copper, zinc, hydrogen. 1, 2, 3, 4, 5, 6. Okay, so these are the 6 elements that we're going to be using in the lab today. And notice how I made copper and iron 2 different colors. The reason why is because copper and iron are going to need a Roman numeral when we name them because they are transition elements with various charges. Hydrogen, magnesium, zinc, and aluminum don't need Roman numerals because they only have a single charge. So that's important. Now, what is a single replacement reaction and how do we figure that out? On the back of this periodic table, if you got a paper one, you have a back. If not, then you can look at the PDF. So there is something right here called the activity series. That is what we're going to look at for single replacement reactions today. Okay, so let's look for our elements. Hydrogen, copper, iron, aluminum, magnesium. 1, 2, 3, 4, 5, 6. So that is the 6. I didn't make them in the different colors, which I should have. So as you move up in this direction, the metals get more reactive. So the most active is at the top, least active, those are the nonmetals, and least active at the bottom. So the top here is the most reactive elements, and they go in order. So the least reactive, look at these elements at the least reactive: gold, platinum, silver. Those are all our precious metals, and that's why they are so valuable, is because they are very unreactive. The elements at the top of this list, lithium, rubidium, potassium, those are reactive in just water. They're actually explosive in water. If you had a necklace made out of lithium or potassium, it would actually catch on fire on your skin because your body is made out of water, and that would be a bad thing. So that's why we make jewelry out of these non-reactive metals down here. You don't need to worry about the reactivity of the non-metals just yet. Notice how hydrogen is in sort of italics there. Hydrogen really is a non-metal, except for when it's in an acid, and we are going to use hydrochloric acid today. So hydrogen is going to be involved, and it's going to act like a metal by being a +1 charge, okay? So we are going to use this reactivity series in order to do the lab today. And you actually don't even really need to see the lab happening. You could just do the entire thing with just this list, but that's not very fun. So that's why we are going to do the different elements, do the lab with the video. So there's my activity series. Got a series of markers here, and we're going to talk about the basic single replacement reaction. Okay, so the basic single replacement reaction goes like this. Here's a metal A, plus a compound, BC, where B is a metal and C is a non-metal. So we're going to have metal A, metal B, and then non-metal C. So what happens in a single replacement reaction is that metal A by itself, the one that's just by itself, must be higher up on the reactivity list than metal B. So if metal A is more reactive than metal B, then this reaction will happen. If metal B is higher up on the list, then no reaction will happen. Non-metal doesn't really matter in this case. So we're looking to compare two different metals to see where they are on this list, to see if this is going to happen or not. And if it does happen, metal A is going to replace metal B and be in the compound. And then B, metal B, gets kicked out. Like, that's sad. It is not reactive enough, so it just gets kicked out. So, and then metal A is all like sinister, like devil face. So that is what's going to happen if the reaction happens. If it's no reaction, that means that metal A was not more reactive than metal B. So let's do an example. I'm going to leave this up here. So one of the experiments that you're going to see today is going to be magnesium, pure magnesium metal, plus aluminum chloride, AlCl3. Now this 3 came from the fact that aluminum is a +1, aluminum is a +3, chlorine is a -1, so crisscrossing those charges, you get AlCl3. That's important, but not important when we go to write the products here. So what you have to remember is that these are the reactants. The products are going to be separate. The products are not the reactants. So if you were to write magnesium with chlorine, you're not going to write MgCl3 because the 3 came from the aluminum. So let's see if this reaction happens. This is metal A, this is metal B, and C. Here is magnesium on the list, and here's aluminum. So is magnesium higher up on the list than aluminum? Yes, only by 1, but yes, it's higher. So magnesium is going to replace aluminum in this compound. Before we can write magnesium with chlorine for A with C plus B, we can just kick out plain old aluminum by itself. We need to write A with C. So A with C. You got to think about Mg and what its charge is. It's a +2, chlorine -1. So crisscrossing those charges is going to give you MgCl2. And then the aluminum gets kicked out. It's the sad one. Now, here's a problem. This reaction is not balanced. So once we have the products, then we just go back and balance the equation. So I've got 1 magnesium over here, 1 magnesium over here, 1 aluminum over here, 1 aluminum. That's all good. But I've got 3 chlorines over here and only 2 chlorines over here. So whenever I have a 3 and a 2, I know I'm going to need a 2 and a 3, a 2 and a 3 for my coefficients. So if I put a 3 here and a 2 here, that gives me 2 aluminum and 6 chlorine. That gives me 6 chlorine over here. So I'm going to need 2 aluminums. And then this also gives me 3 magnesiums. So go over here and give it a 3 for magnesiums. So the final balanced chemical equation for this reaction, oops, it's the wrong end, is going to be 3Mg plus 2 AlCl3, and then yields 3 molecules of MgCl2 plus 2 Al. So that is the final balanced chemical equation, and you can use this one in your lab because this is one of the ones that you've got to write. All right, what about if we're using one of those transition metals? So one of the transition metals that we've just learned about, iron and copper are both transition metals that are going to be in the lab today. So let's look at an example for that. All right, so we're going to write the regular equation for single replacement again. B, C. It's A with C, and then B gets kicked out. So that's the basic equation for single replacement reactions. Let's do magnesium, again, plus copper 2 chloride. How do I know that's copper 2 chloride? Because the compound Cl was a -1. That means that this 2 had to have come from copper. So this is going to be copper 2 chloride. So is this reaction going to happen? So we got to check our chart. Is metal A more reactive than metal B? So we're looking at magnesium and copper. Magnesium's here, copper's way down here. So copper is very unreactive. That's another reason why copper is used a lot. It's very valuable. You might have copper pipes in your house because copper doesn't react with much. So magnesium is going to replace copper in this reaction. So for our A with C, A, B, C. A with C is going to be the magnesium with the chlorine, and then B is going to get kicked out over here, which is just the copper. So when you have a plain element like this, unless it's hydrogen, hydrogen's the only one because it's a diatomic, it's just going to be plain copper. So again, the magnesium is a +2, the chlorine is a -1. So crisscrossing those charges here, this is a 1, it's going to be MgCl2. And then this one might already be balanced actually. So we've got 1 magnesium, 2 chlorine, 2 chlorine, 1 copper, 1 copper. So that is all well and good for that one. Now, what about a reaction that's not going to take place? Let's take a look. How about aluminum plus MgCl2? So we're looking to see if aluminum is higher up on the list than magnesium, and aluminum will replace magnesium in that compound. So aluminum is not higher up on this list. So magnesium is going to be strong enough to hold the bonds between the magnesium and the chlorine that there will be no reaction here. So in that case, we write no reaction. So for the lab today, you are going to compare each of the metals with the compounds. Watch the lab video, and you'll be able to see the reactions happening, but it may not be very obvious. So if it's not too obvious and you're not sure if there's a reaction or not, all you have to do is look at the reactivity series on the paper, and then you'll know if the reaction happens or not. If the single metal by itself is higher up on the list than the one that's in the compound, then the reaction is going to happen. It's going to be a yes. At the end of the lab, you'll count up all of your yeses to which metal was more reactive and see if you get the same order as this list. All right, let's try it out.